Alright, good afternoon. This lesson is for my Honors Integrated 1 class. I'm going to try and navigate around my big dog Thursday. She's just laying in the middle of the floor. I hope everyone's doing alright. There's going to be 2 videos for this lesson. The first video is going to be taught with isosceles triangles, and the second video is going to be taught with equilateral triangles. I'd like to do 2 videos because I mean they're I think it would kind of help break up the lesson in this, so you're not spending so much time looking at these concepts. If they're here, lay down, bud. Come on, let's lay down. Lay down. Lay down. So let's go ahead and get started with our lesson. Our first goal is going to be to define. Yeah, Thursday. Our first goal is going to be to define an isosceles triangle. And then our second goal, and I only put 1 mark, our second goal, goal 2, is going to be to use corresponding parts of congruent triangles are congruent to prove what isosceles triangles do. And we're going to also prove the converse to this. And so let me just go ahead and jump right in. Now, I have 2 triangles on the board, and I'm going to try and show you how this all works using this setup. But I'll start off with our first goal, and our first goal is to define an isosceles triangle. And an isosceles triangle has at least 2 congruent sides. So for this triangle, I can say that 2 sides are congruent. It could be 3, but it's at least 2. So let's mark that in there, and I'll label this triangle. We'll go A, B, and C. All right. So again, I mentioned I want to move on to goal 2, and goal 2 is going to be using corresponding parts of congruent triangles to prove what isosceles triangles do. So you know, I do have a 2-column proof, and I guess it's good to see the structure of this. It's going to be a very how do I say this? Light overview of the proof. So I'm going to tell you what our given here is. We'll say our given is isosceles. Is it C or S? I don't know how to spell. Isosceles triangle ABC. And I probably did spell that wrong, so let me highlight my spelling mistake. And our goal here, what we're going to try to argue using corresponding parts of congruent triangles are congruent, is I want to argue, when this is all said and done, I want to argue that angle A is the same as angle B. Alright, so this is going to be our proof. This is what I'm starting off with. This is what I want to end up with. And let me just tell you the overview of this. We need to use a construction. Alright, I need to build 2 triangles, and then I need to argue my triangles are congruent. And then once I've argued that I have identical triangles, we can then conclude that the parts in the same positions themselves must also be identical. So this is the structure to what we are doing today. Okay, so let's see here. I'll do the construction. Well, let's start with this. Alright, so my first statement that I'm going to claim is I'm going to claim that I have an isosceles triangle. I think it's SC for some reason. Isosceles triangle ABC. And the reason why I can make this claim is that is what I'm starting with. Okay, this is given to us. Alright, so the next thing I'm going to do is I want to bisect. I'm going to bisect angle C. And the reason why I can bisect angle C is it's a construction. It's a legal move. And the benefit for us doing this bisecting is I get 2 triangles out of this move. So this is why I'm doing this. And it also allows me to make my congruent triangle argument, which you will see here in a quick second. So I'm going to cut this guy in half. this angle bisector will say hits the triangle at point D. All right. So now I've actually set up enough that we can go ahead and make this congruent triangle argument. So let's see here. I have, I know that side CA is congruent to side CB. I don't know why I erased that. And that's true because these are the sides of my isosceles triangle, right? So I'm going to say this is true because triangle ABC is isosceles. Thought that was an A. It was a triangle symbol. Triangle ABC is isosceles. My next thing I'm going to say, so I've got a side, right? The next thing I'm going to say is I've got angle ACD is the same as angle BCD, and that's because we bisected the angle. So angle ACD is the same as angle BCD, and this is true because we bisected angle C. And the next thing I'm going to say, I've got my side, I got my angle, I got my next side. The next thing I'm going to say is I'm going to say that side CD is the same as side CD. And that is true because of the reflexive property. Now I've created, through this, I've created side, angle, side. Side, angle, side. So I can now say that I have two identical triangles. Let me get the right lid on the right pen. So I can now say that triangle ACD is congruent to triangle BCD. Okay, and this is true because we have the side, angle, side, triangle congruence criteria. Right? And so I've argued that this little triangle is the same as that little triangle. Now, remember, we always want to keep our eye on the prize and know what we're arguing to. And notice that angle A is the side, or the angle A is next to the side with the 1 mark and the no mark, as well as angle B. Angle B is next to the side with the 1 mark and the no mark. So I can reach my final conclusion and say that angle A is congruent to angle B. And this is because of corresponding parts of congruent triangles are congruent. Alright, so anytime that we see an isosceles triangle, I'm going to erase everything I've done in here. Oh, the mailman dropped off mail. It's probably the most exciting time of my day nowadays. Alright, so let me erase this. Alright, so if I start with an isosceles triangle, alright, if I start with an isosceles triangle, that means that I know that we must have two congruent angles. So having this makes these, okay? That's this part of our second goal. Okay, now there's another idea. It's called the converse. So we're going to change the order of the idea. We will start with this, and we're going to argue that the triangle must be isosceles. So that's actually kind of a simple argument to do if you've actually seen, you just saw it, I just did it for you. if you do to this triangle what we did to that one, if I bisect this angle, then I make two triangles, and I've made a triangle now that has an angle, and a side that's the same as this other triangle that has the same angle and side, and so therefore we can conclude that those two small triangles are congruent, and since the two triangles are congruent, the parts in the same position must be congruent, and therefore we have a triangle that has two congruent angles. That triangle must be isosceles. So if you start with this, you end up with this. If you start with this, you end up with this. So you got to figure out what you're starting with. Okay. So that's going to be our first video. I thought I was going to do the proof, but that I'll kind of leave that one blank. Remember, this lesson is for 22.2. I will work on the next video here shortly. I hope everyone's doing okay out there. And please, again, email me or ask me a question on the Remind app if you have any questions, and I'll get back to you as soon as possible. Take care, everybody.